Find the maximum inelastic drift in the second story in inches. In this problem, the normal and deformed outline of a three-story building is shown. The total displacement between each story and the ground is provided in inches. And the building is a large school built with a special steel moment frame. The maximum inelastic drift of a story, delta x, equals the deflection amplification factor, CD, times the maximum elastic drift in a story, delta XE, all divided by the occupancy importance factor, I. We'll begin by solving for the deflection amplification factor. To do so, we'll turn to Table 12.2-1 in ASCE 7, which lists CD values for different seismic force resisting systems. Since the school is constructed with a special steel moment frame, the deflection amplification factor equals 5.5. Next, we'll determine the maximum elastic drift. Since the problem states to find the maximum inelastic drift in the second story, a subscript 2 is added to both drift terms in the equation. The elastic drift in the second story can be calculated by subtracting the total displacement in the first story from the total displacement in the second story. And the second story elastic drift equals 0.60 inches. Lastly, we'll solve for the occupancy importance factor, I. Table 11.5-1 from ASCE 7 shows the occupancy importance factor depends on the occupancy category. According to Table 1604.5 of the 2006 International Building Code, buildings with large numbers of persons, such as schools with more than 250 students, have an occupancy category of type 3, and therefore an occupancy importance factor of 1.25. Returning to the original equation and plugging in all the variables on the right-hand side, the maximum second-story inelastic drift equals 2.64 inches. When reviewing the possible solutions, the answer is D.